Welcome to section 4.5. Today we're going to practice using our table a little bit more for undetermined coefficients. So bust out your table and take a look at it. The second superposition theorem will help us justify some of the things we use in our table. Now, rather than read through the theorem, I'm going to look at an example with you. Suppose we have two solutions, y1 and y2, of two differential equations, but the left-hand side of each differential equation is the same. The only thing that changes is the right-hand side. So if you read that theorem above, the f1 would be sine t, and the f2 would be e to the 2t. And we want to find a solution to two differential equations where the right-hand side is a combination of f1 and f2. So in example A, the right-hand side is 2f1 plus 3f2. So a theorem would tell us that a solution would be 2y1 plus 3y2. Now we're given y1 and y2. y1 is cos t, so this is 2 cos t, and y2 is a third e to the 2t, so this would just be e to the 2t. And there's our solution. Okay, pause the video and see if you can do the next one. All right, so this is negative 4f1 plus 18f2. So we want y equal to negative 4 y1 plus 18 y2. Well, that's negative 4 cos t plus 6 e to the 2t. Okay, now we're going to practice using our table a little bit more. And we're just going to be writing down trial yp's, and we're not going to be checking for repeats because we don't know what yc is. So this is just practice using the table. All right, the first one is a cubic polynomial. So our trial yp would be a generic cubic polynomial. At cubed plus bt squared plus ct plus d. Even though there are missing terms in f, we still need to account for all the terms in yp. Okay, next one, we've got cos 2t, and in front of cosine, there's just a constant, a 1. So we want a constant, a cos 2t, plus another constant, b sine 2t. Even though there's only a cosine 2t, we need both a cosine and a sine term. Okay, let's look at the next one. Actually, maybe you should pause the video and try this one yourself. All right, so we've got a linear polynomial times cosine t. So we want at plus b, a linear polynomial, cos t, and then another linear polynomial, ct plus d, sine t. Make sure you don't make the mistake of doing this. At plus b, c cos t plus d sine t. That won't work. You need to write it just as I have it. Okay, the next one is a combination. We've got an f1 and an f2, and by the superposition theorem that we just looked at, our trial yp can be written as a yp1 and a yp2. Our yp1 would be a cos 2t plus b sine 2t, and then our yp2, so this is yp1, our yp2 would be c cos t plus d sine t. So don't make the mistake of using the same letter. If you've used a and b, you can't use them again in yp2. You need to change letters. All right, next one, again, we've got the sum of an f1 and an f2. So first I need a quadratic polynomial. So my yp1 is going to be at squared plus bt plus c, and my yp2 is going to be a constant times e to the 5t. So d e to the 5t. All right, and the last one is also a combination of an f1 and an f2. So for yp1, I need a linear polynomial, at plus b, e to the negative t. And for my yp2, I need a c cosine t plus d sine t. Okay, now we're going to take it up a notch. I've already written down in each case the trial yp for each f. So I've given us f, given us the trial yp, but I've also given us yc. So now we're going to be checking for repeats. So in this first one, we say, okay, are there repeats between our trial yp and our yc? And we see, yes, there's a repeat right here. So I need to multiply by t. So my final yp would be at e to the negative t. Okay, next one. Got a quadratic polynomial, and so I'm looking for repeats. Do I see one? Yes, there's a constant here and there's a constant here. So again, I need to multiply the whole yp by t to get at cubed plus bt squared plus ct. Okay, the next one in your lecture notes, there'll be no cosine there, and this term will be missing. All right, and so this is our yp1, and this is our yp2. And if there are repeats, we're only going to multiply the offending yp by powers of t. So I'm looking for repeats, and I don't see any repeats in yp2, but I do see a repeat in yp1. I see a constant. So I'm going to multiply yp1 by t, and I'm going to leave yp2 alone. So my final yp will be at squared plus bt, and then I'll have c e to the negative t. Okay, next one. I have no repeats because of this e to the 3t in each term is saving me. So if there are no repeats, I'm just going to write same. And for the last one, I do see a repeat. If I distribute, I'm going to get a constant times cos 2t and a constant times sine 2t. So I need to multiply this whole thing by t. So my final yp is at cubed plus bt squared plus ct cos 2t plus dt cubed plus et squared plus ft sine 2t. Okay, and we're going to finish up with just another example of how to use undetermined coefficients from start to finish. So we want to find the general solution to this differential equation. Step 1, we need to solve the associated homogeneous differential equation for yc. So the characteristic equation for this is r squared minus 1 equals 0, which factors as r plus 1, r minus 1 equals 0. So r is 1 and negative 1, those are my two roots, and my yc is c1 e to the t plus c2 e to the negative t. Step 2, I write down my trial yp. So my f of t is negative 11t plus 1. So my trial yp is going to be a linear polynomial, at plus b. I look for repeats and I see there are none. So that is also my final yp. So I can go ahead and find yp prime, which is a, and yp double prime, which is 0. Step 3, I plug that information into my original differential equation. So y double prime is 0. I subtract y, which is at plus b, and I set that equal to negative 11t plus 1. Now I'm going to equate coefficients. On the left, I have negative at minus b, and on the right, I have negative 11t plus 1. So that tells me that negative a is 11, and, negative a is negative 11, and negative b is 1. So a is 11, and b is negative 1. So my yp is 11t minus 1. And my general solution is yp plus yc, which is 11t minus 1 plus c1 e to the t plus c2 e to the negative t. And that is the end of this section.